Aluminum alloy conductors present several advantages. Firstly, they are lighter. Aluminum has a density of 2.7 grams per cubic centimeter, while copper has a density of 8.96 grams per cubic centimeter. This significant difference makes aluminum conductors considerably lighter than copper, an advantage particularly beneficial for overhead lines and large-scale electrical installations. Secondly, aluminum is more flexible. Aluminum is a more ductile metal than copper, granting aluminum conductors greater flexibility. This enhanced flexibility simplifies handling and bending, reducing both installation time and effort. Thirdly, aluminum conductors possess a higher short-circuit withstand capability. Aluminum conductors boast a higher specific heat capacity compared to copper conductors. This characteristic enables them to endure short-circuit currents for extended periods without experiencing overheating or melting. Furthermore, aluminum is cost-effective. Aluminum is generally less expensive than copper, establishing aluminum conductors as a budget-friendly option. However, aluminum alloy conductors also have several drawbacks. Firstly, they exhibit lower conductivity. Aluminum has a lower electrical conductivity than copper, specifically 61% International Annealed Copper Standard versus 100% International Annealed Copper Standard. This difference necessitates a larger cross-sectional area for aluminum conductors to carry the same current as copper conductors. Secondly, they present higher resistance. The low conductivity of aluminum results in higher resistance compared to copper conductors. This can lead to increased power losses and voltage drop, particularly over long distances or under high loads. Thirdly, there is corrosion susceptibility. Aluminum is more susceptible to corrosion than copper, especially in outdoor environments. This can cause reduced conductivity, connection failures, and ultimately shorten the lifespan of the conductor. There is also joint compatibility to consider. Aluminum conductors require specialized connectors and jointing techniques to ensure proper electrical contact. Mixing aluminum and copper conductors can create galvanic corrosion. Also, aluminum is less mechanically strong. While aluminum is lighter, it is also less mechanically strong than copper. This means that aluminum conductors may require additional support or reinforcement to prevent sagging or damage under load or environmental stresses. There are also additional considerations. Local electrical codes and standards may have specific requirements for the use of aluminum conductors, such as minimum conductor size, jointing methods, and temperature ratings. Environmental factors such as corrosion should be considered when selecting aluminum conductors. Protective coatings or other measures may be necessary to ensure long-term performance. Aluminum alloy conductors are commonly used in overhead transmission lines, distribution systems, and industrial applications where weight and flexibility are important. However, they may not be suitable for all applications due to their lower conductivity and corrosion susceptibility. When selecting aluminum conductors, it's essential to carefully consider factors such as the application, environmental conditions, and code requirements. Proper installation techniques, including the use of appropriate connectors and jointing methods, are crucial to ensure long-term reliability and safety. Aluminum's higher coefficient of thermal expansion compared to copper can lead to loosening of connections over time, especially with temperature fluctuations. Therefore, regular inspection and maintenance of aluminum connections are important. Oxidation of aluminum can create a high-resistance layer that impedes current flow. The use of joint compounds specifically designed for aluminum can help prevent oxidation and maintain a good electrical connection. When transitioning from copper to aluminum conductors, it's important to recalculate conductor sizes to ensure adequate ampacity for the intended load. This is due to aluminum's lower conductivity, which requires a larger conductor size to carry the same current as copper. Aluminum conductors are more prone to damage from mechanical abrasion or sharp bends than copper conductors. Therefore, careful handling and installation practices are necessary to avoid damaging the conductor. The type of insulation used on aluminum conductors should be compatible with aluminum and rated for the intended application and environmental conditions. Some insulation materials can react with aluminum, leading to corrosion or degradation of the insulation. When using aluminum conductors in direct burial applications, it's important to ensure that the soil is not corrosive and that the conductors are properly protected from moisture and mechanical damage. Direct burial aluminum conductors should be specifically rated for such applications. For terminations, using dual-rated connectors is preferable when connecting to other materials. Dual-rated connectors are made to handle both materials. Periodic inspection and tightening of connections are recommended. As a final recommendation when connecting to equipment, ensure the equipment is rated for aluminum conductors. The use of aluminum conductors in specific applications, such as branch circuits in residential wiring, has been a subject of debate and code revisions over the years. It's important to consult the latest version of the National Electrical Code, or NEC, and local codes to ensure compliance with all applicable requirements. In some cases, the use of aluminum conductors may be restricted or require specific installation methods. When using aluminum conductors in corrosive environments, it's important to consider the use of corrosion inhibitors or protective coatings to prevent degradation of the conductor. These coatings can help to extend the lifespan of the aluminum conductor and maintain its electrical performance. When selecting aluminum conductors, it's important to consider the temperature rating of the conductor and ensure that it is suitable for the intended application. The temperature rating of the conductor indicates the maximum operating temperature that the conductor can withstand without degradation. Aluminum conductors are available in a variety of alloys, each with different properties and characteristics. The selection of the appropriate alloy will depend on the specific application and the environmental conditions. Some alloys are more resistant to corrosion, while others have higher strength or conductivity. When using aluminum conductors applications where vibration is present, it's important to ensure that the connections are properly secured to prevent loosening. Vibration can cause connections to loosen over time, leading to increased resistance and potential failure. The use of lock washers or other vibration-resistant hardware can help to prevent this. When using aluminum conductors in applications where the conductors are exposed to sunlight, it's important to use conductors that are rated for sunlight resistance. Sunlight can degrade the insulation on some conductors, leading to cracking and eventual failure. Sunlight-resistant conductors are designed to withstand the effects of sunlight and maintain their integrity over time. When using aluminum conductors in applications where the conductors are subject to mechanical stress, it's important to use conductors that are rated for mechanical strength. These conductors are designed to withstand the forces that are applied to them without breaking or deforming. The use of proper support and strain relief can also help to reduce mechanical stress on the conductors. When using aluminum conductors in applications where the conductors are exposed to chemicals, it's important to use conductors that are resistant to those chemicals. Some chemicals can corrode or degrade the insulation on conductors, leading to failure. Chemical-resistant conductors are designed to withstand the effects of chemicals and maintain their integrity over time. When using aluminum conductors in applications where the conductors are exposed to extreme temperatures, it's important to use conductors that are rated for those temperatures. Extreme temperatures can cause conductors to expand or contract, leading to stress on the connections and potential failure. High-temperature conductors are designed to withstand extreme temperatures and maintain their performance over time. Aluminum building wire, specifically Alloy AA8000 series, addresses many concerns associated with older aluminum wiring. Alloy AA8000 series aluminum wire offers improved strength, ductility, and corrosion resistance compared to earlier aluminum alloys used in building wiring. These improvements make it a suitable and safe alternative to copper for many residential and commercial applications when installed correctly. Alloy AA8000 series aluminum wire exhibits comparable ampacity to copper conductors of the same size. However, due to aluminum's lower conductivity, it is crucial to use appropriately sized conductors based on the ampacity requirements outlined in the NEC. Using undersized aluminum conductors can lead to overheating and pose a fire hazard. Terminated aluminum conductors requires careful attention to detail and the use of appropriate connectors and techniques. Oxide buildup on aluminum surfaces can create a high resistance connection, leading to heat generation and potential failure. Using connectors specifically listed and labeled for use with aluminum conductors, along with an oxide-inhibiting joint compound, helps to ensure a reliable and safe connection. These connectors are typically made of aluminum or are plated with aluminum to prevent galvanic corrosion. Applying an oxide-inhibiting joint compound to the aluminum conductor before termination helps to prevent oxide formation and improves conductivity. These compounds typically contain zinc particles that create a conductive bridge between the conductor and the connector. Proper tightening torque is essential for creating a secure and reliable connection. Using a torque wrench to tighten connectors to the manufacturer's specified torque value ensures that the connection is tight enough to provide good electrical contact, but not so tight as to damage the conductor or connector. Antioxidant compounds should always be used when aluminum conductors are connected to other metals such as copper. Periodic inspection and maintenance of aluminum connections are recommended to ensure their continued reliability. Over time, connections can loosen due to thermocycling, vibration, or corrosion. Regularly checking and retightening connections as needed helps to prevent overheating and potential failures. Using the right tools for stripping and terminating aluminum conductors is important to avoid damaging the conductor. Wire strippers specifically designed for aluminum conductors help to prevent nicks and cuts in the conductor, which can weaken it and increase the risk of failure. When installing aluminum conductors, it is important to follow all applicable codes and standards, including the NEC and local electrical codes. These codes provide detailed requirements for the installation of aluminum conductors, including conductor sizing, termination methods, and grounding requirements. Properly grounding aluminum conductor systems is essential for safety. Grounding helps to protect against electrical shock and provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse. Using the correct type and size of grounding conductor and making sure that all connections are tight and secure are crucial for effective grounding. When transitioning from copper to aluminum conductors, it is important to consider the potential for galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte such as moisture. The more active metal corrodes, while the less active metal is protected. Aluminum is more active than copper, so it will corrode when in contact with copper in a moist environment. Separating aluminum and copper conductors with an insulating material or using connectors specifically designed to prevent galvanic corrosion can help to minimize this risk. It is crucial to educate electricians and installers on the proper techniques for working with aluminum conductors. Proper training and education can help to prevent errors and ensure that aluminum conductors are installed safely and reliably. Many electrical training programs offer courses on aluminum conductor installation. When using aluminum conductors in underground applications, it is important to protect them from corrosion. Underground environments can be particularly corrosive, especially if the soil is acidic or contains high levels of salts. Using corrosion-resistant conductors or protecting them with a corrosion-inhibiting coating can help to extend their lifespan. In summary, aluminum alloy conductors offer several advantages, including lighter weight and cost-effectiveness. However, they also have some disadvantages, including low conductivity and greater susceptibility to corrosion. By understanding these pros and cons and following proper installation techniques, you can use aluminum conductors safely and effectively in a variety of applications. Aluminum alloy conductors are increasingly being used in renewable energy systems such as solar and wind power installations. Their lightweight makes them ideal for overhead transmission lines, while their low cost can help to reduce the overall cost of these projects. The use of aluminum conductors in these applications requires careful consideration of the environmental conditions and the potential for corrosion. High-voltage applications also often employ aluminum conductors due to weight savings. Regularly inspect aluminum conductors, especially in harsh environments. Look for signs of corrosion or damage, and address any issues promptly. The electrical installation should also ensure the aluminum conductors are correctly supported and not under undue strain. When upgrading an existing electrical system, consider the compatibility of aluminum conductors with existing copper conductors. Use appropriate transition connectors to avoid galvanic corrosion. When splicing aluminum conductors, use compression connectors designed for aluminum and follow the manufacturer's instructions. Use the correct crimping tool and die for the connector size. This ensures a secure and reliable connection. Clearly label all aluminum conductor connections to indicate the presence of aluminum wiring. This helps prevent accidental mixing of dissimilar metals and simplifies future maintenance. Keep records of all electrical work performed, including conductor types, sizes, and connection methods. This documentation is valuable for future troubleshooting and maintenance.